Okay, guys and girls, so this should be a quite a short and sweet topic because there's not much to say. So this topic is about metallic bonding, and then we're going to talk a bit about transition metals. Okay, so transition metals will have metallic bonding because they are metals. So if you look here, what we've got here, these positive centers here represent the positive center of the metals. Okay, and what you've got here around the positive metals are these electrons. Now the electrons around metals are free to move. They are free to move around. Right. So these electrons are really free to move around, and we call these electrons, and the reason why I've colored them in blue is we call them a sea of electrons. That's why I colored them in blue. So metallic bonding consists of positive centers and a sea of electrons that are free to move. See how that rhymes? Free to move. Now, when a potential difference is added to a metal, hello.
Do you know who you voted for? Do you know what the man's name was called?
What was it? Tell me, I don't know.
His name was called Jeremy Corbyn.
Oh my goodness, how do you know that?
'Cause
Where did you learn that from?
school.
Oh, really good.
His name is Jeremy Corbyn.
Ah, yes, Jeremy Corbyn, the Labour man.
You voted for Jeremy
Oh
Corbyn.
my goodness, you're so clever. Okay, baby, I'm making this a YouTube video now. Can I carry on with it?
Yeah.
Thank you. Okay, so they are a bit of politics for you from a 5-year-old. Okay, so anyway, when we apply a potential difference, that means a voltage to this metal, right? So if we apply a voltage, so this is my battery, my cell rather. If we apply voltage, which is a potential difference, aka potential difference, difference. That's amazing. They're teaching these kids in nursery about this kind of stuff, about politics and stuff. Really interesting. Anyway, if you add a potential difference to this sea of electrons, to this metallic bonding, it's going to make the electrons move in one direction. And because we have a movement of electron in one direction, this is going to make a current flow. And the movement of electrons, or a current flowing, is electricity. So we know now that metallic bonding and metals can conduct electricity, and we know why now. It's because they have these free delocalized electrons that are able to move. Okay, and these are delocalized electrons. Okay, so delocalized electrons is another word, another way of saying that they are free to move, and we describe it as a sea of electrons. So that's one of the properties of metals, is that they can conduct electricity. Now another property of metal is that we can bend them into shape, and this is called being malleable. Okay, so metals are quite malleable. I'm going to explain how that works. Now let's suppose that I get a hammer. So here's my hammer, right, and I'm going to smash this here. I'm going to use my hammer, obviously my amazing drawings, and I'm going to smash this hammer into my metallic bonding, right? I'm going to smash it a couple of times. So this is smash, 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 smash. What's going to happen is the positive centers will move inwards. So the positive centers will cause bending. Okay, so that will bend. However, it doesn't break because the electrons hold the positive center in place. Electrons hold the positive centers in place, and so as a result we can bend metal into shape. So we can bend metals into shape. Now this has a special word. The word is metals are malleable. You can hammer them, bend them into shape. And now you know why. It's because the positive centers will move, however the negative electrons will keep them from completely collapsing, keep them from completely breaking, and so we can have metals being bent into shape. And that's really what you need to know about metallic bonding. So what I'm going to do, I'm going to get rid of all of this, and then I'm going to bring up our periodic table and just talk to you a little bit about transition metals. Okay, so I have covered transition metals in a previous video, but I'm just going to talk really about 2 points. Number one, here, this middle block here are transition metals. Okay, so I'll make this a little bit less opaque. Okay, so this is our middle block, right? So all of this to all of this, right, all of these are transition metals, every single bit of that. Now transition metals, what you need to know about is, as we've said already, they form colored compounds. And the second thing that you need to be aware of is they form they have a very high melting and boiling point. Okay, they have a high melting point, so it's going to take a lot of energy, a lot of heat energy to melt it. That means, of course, melting is turning from a solid to a liquid. So that's what you need to know about transition metals, sorry. Is that okay, people? Right. Next is going to be my favorite 2 topics. Brilliant. I'll see you on the other side.